So we said we're going to simplify the left side. Up top, our numerator, we have secant squared minus 1. Does that look like one of our trig identities? Yeah, it looks like one of our Pythagorean identities. So like we said yesterday, if you have a trig function squared, especially if it's attached to a 1, you're probably going to use your Pythagorean identities. Bless you. So we want to get our secant squared minus 1 on top. We can make it subtract 1. This would be tangent squared is equal to secant squared minus 1. So I'm going to replace the secant squared minus 1 with tangent squared. And then on the bottom, we have secant squared still. So that simplified it a little bit. We're still not quite to sine squared, which is our goal. We want to simplify it all the way down to sine squared. What could we do next? It might help to change everything in terms of sine and cosine.
Change the tangent into sine over cosine.
Perfect. Let's do that. So we're going to change tangent to be sine over cosine. But since it's tangent squared, we're going to make it sine squared over cosine squared. Over, I can change secant squared to 1 over cosine. So make it 1 over cosine squared. What do we do if we have a fraction in a fraction? Keep, change, flip. We're going to keep the top, change to multiplication, and flip the bottom. So I'm going to flip it to cosine squared over 1. Do we see anything that'll cancel? Awesome. We have a cosine on the top and on the bottom, or cosine squared on the top and the bottom. So those cancel. So we're left with sine squared over 1, which would just be sine squared. What was our goal? Sine squared. So that would be our answer. So for example 2, I'm going to draw a brick wall right down the middle. We can't move things from one side to the other. Which side do we want to simplify first? The right side. You always want to start with the more complicated side because it'll be easier to condense it down. So on the right side, we have 2 terms here. We're adding 2 things together. On the left side, we just have a secant squared, or 2 secant squared. So ideally, we'd like to add these 2 things together, make it 1 term, see what we can do to simplify from there. What would we need if we're adding fractions? Same denominator. So here, I can multiply by 1 minus sine. So I have to multiply that to the top and the bottom. So 1 minus sine. And then on the left side, I'm going to multiply it by 1 plus sine. So on top, we have 1 plus sine plus 1 minus sine. And then on the bottom, we can multiply the bottoms together. 1 plus sine times 1 minus sine. These are conjugates, so we can do our conjugate shortcut. A squared minus b squared. If you forget your conjugate shortcut, just FOIL it out. Our a would be 1, so 1 squared is 1. Minus b is sine, so sine squared. See anything that will simplify? 1 minus sine squared simplifies. Let's put our identities here so we can see. What does 1 minus sine squared simplify to? Awesome. If I subtracted sine squared, moved it to the other side, cosine squared is equal to 1 minus sine squared. So I can replace that 1 minus sine squared with cosine squared. Anything in our numerator simplify? Sine minus sine cancels. And then we have 1 plus 1. What's 1 plus 1? 2. So this would be 2 over cosine squared. Let's look back. What's our goal? Our goal is 2 secant squared. We're almost there. What's 1 over cosine simplified to? Secant. So we can change this to be 2 secant squared. So that would be our answer, which is the same as the right side, or the left side. So with these questions, it gives you the answer. It tells you what you're trying to find. You just have to show the work of simplifying it. Example 3. Let's draw a brick wall right down the middle of the equal sign. Which side do you think would be better to simplify here? The left side. Left side's more complicated, so let's start with that. I'm going to put my identities here to help us. What should we do first? We can change tangent squared plus 1 to be what? Secant squared. Perfect. So I'll replace that with secant squared. And then we have cosine squared minus 1. I can rearrange my Pythagorean identities to be cosine squared minus 1. I got to subtract 1 to move it to the left side and subtract sine squared. So we have cosine squared minus 1 is equal to negative sine squared. So what would cosine squared minus 1 get replaced with? Negative sine squared. Awesome. All right, so that was helpful. Still have some more simplifying to do until we get it just to be tangent squared. What could we do next? We can make secant squared 1 over cosine squared times negative sine squared x. I can make it negative sine squared x over 1. Combine these together. So we get negative sine squared over cosine squared. Bless you. What's sine over cosine simplified to? Tangent. So this would be negative. Since they're both squared, it'd be negative tangent squared. What was our goal? Negative tangent squared. So we're done. So let's draw our wall down the middle. Which side do you think would be easier to simplify here? I think the left would be easier. So notice how on the left side we have 2 terms. They're separated by a plus. On the right side, it's kind of like just 1 term because they're being multiplied. So maybe we can try to add these 2 together to where it's just one thing. So let's simplify the left. There's more than one right way to do these questions. Your work could be different than somebody else's, but you'll still end up with the same answer. So there's more than one right way to do these. Just make sure you're simplifying correctly. Let's simplify the left side. What would you want to do to simplify the left side?
Sine over cosine plus cosine.
Awesome. Let's change tangent to be sine over cosine. And cotangent we can change to cosine over sine. Now we said before our goal is to add these together to be one thing. So how would I add these together? What do I need? Common denominator. So I'm going to multiply the top and the bottom here by sine. I'll make our common denominator sine times cosine. And then I'll multiply the top and the bottom here by cosine. So we get sine squared plus cosine squared over sine times cosine. Sine squared plus cosine squared. We've seen that before. What does that equal? 1. Awesome. So let's replace that with 1. So we have 1 over sine times cosine. What's 1 over sine? Cosecant. What's 1 over cosine? Secant. So we have cosecant times secant. Is that the same thing as secant times cosecant? Yeah. We can just replace it. Saying 2 times 4 is the same thing as 4 times 2. The order that you multiply doesn't matter. So we can switch the order if we want, just so it's exactly the same. So what I did here was I split it up by multiplication. So I said 1 over sine times 1 over cosine. Let's look at example 5. Which side do you want to simplify first? Sure, we could simplify the right. I would suggest the left here, even though the right looks a little bit more complicated because it has a fraction. I would maybe simplify the left just because on the left side we can change everything to be in terms of sine and cosine and simplify from there. So let's do the left. Again, there's more than one right way to do these questions. You can simplify the left. You'll still get the same correct answer. Your steps are just going to look a little bit different, but that's totally fine. I would say let's simplify the left side. Yeah. What's secant in terms of sine and cosine? 1 over cosine. What's tangent in terms of sine and cosine? Sine over cosine. If we're adding fractions, what do we need? Same denominator. We have a common denominator here, so we can just add our numerators together. So 1 plus sine over cosine. It's almost the same thing. Not quite. Any suggestions of what we could do next? If you wanted to, we can stop here on the left side and now simplify our right side a little bit more. So if you're stuck on the left side and you're like, oh, I don't know what else to do, let's pause and we'll look at the right side, see if we can simplify that a little bit more. What can we do to the right side to simplify?
Oh. Separate the 1 plus sine x.
We can't do that.
Could you change it to cosine squared? The denominator?
Let me answer Santi's question and then.
No, never mind. I'm done. Because I was trying to just get it back to the stuff you just did.
Right. So if we did that on the left side and separated it into 1 over cosine and sine, it would just take us right back to the beginning. So it's a good idea, but not quite. We can't change 1 minus sine to cosine because it's not squared. So we can't use our Pythagorean identity. But we could multiply by the conjugate and make it a Pythagorean identity. So we can multiply by 1 plus sine on the top and the bottom. On the top, I'm not exactly sure really what my goal is yet. So I'm not going to distribute the cosine yet. I'm going to leave it as cosine times 1 plus sine for now. Let's see where we get here. In our denominator, these are conjugates. So we can use our conjugate shortcut, a squared minus b squared. If you forget your conjugate shortcut, just FOIL it out. So a would be 1. So 1 squared is 1 minus sine squared. Now can we use one of our Pythagorean? Yes. What's 1 minus sine squared?
Can you pull it up?
Yes, I can pull it up. There we go. So if I subtracted sine squared, 1 minus sine squared would be cosine squared. So I can replace this with cosine squared. See anything able to simplify on the right side now?
Yes.
What?
Cosine.
Cosine. I've got a cosine that's being multiplied to the top and 2 on the bottom, so I can take one of the 2 out. So then I'm left with 1 plus sine over cosine. And that's exactly what we were going for. So we're done. So it is possible. You can simplify both sides. You just can't move something from one side to the other. But if you simplify one side and you can't get anywhere else, pause, then go and simplify the right side or the other side. So let's draw our wall right down the middle. Any suggestions here to start?
You could start with the right.
We can.
So then we could do the Pythagorean identity on the top.
Can we do the Pythagorean identity on the top?
Oh, no, you can't.
No, because it's not squared. So we can't. Any other suggestions? We could do the left side. What do you want to do on the left side? We can do the Pythagorean identity on top if we wanted to. So because it's cotangent squared, what would cotangent squared equal? So we're looking at this one here. Awesome. So cosecant squared minus 1. So we're going to replace that with cosecant squared minus 1 over 1 plus cosecant squared, or cosecant. Any ideas of what we can do next? Looking at the numerator here, cosecant squared minus 1, can we factor that?
Yeah.
How?
Difference of squares.
Difference of squares. So that they're both perfect squares, just like we did yesterday. It would factor into cosecant plus 1, cosecant theta plus 1, and cosecant theta. Yeah. Minus 1. 1 plus cosecant theta. Anything the same on the top and the bottom? Yeah, I've got a cosecant plus 1 and 1 plus cosecant. These are the same thing. Saying 1 plus x and x plus 1 are the same when you're just adding them both. So we can cross those out since it's being multiplied on top. So when we cross them out, we're left with cosecant minus 1. Any ideas of what we could do next?
Go to the other side.
We can go to the other side. Now our left side's more simplified than the right side. So maybe let's pause on the left side and let's look at the right side. What can we do to simplify the right side?
Would you have to, like, split it up?
We can split it up, yeah. So we can make it 1 over sine minus sine over sine. When you do this, be careful because when you're adding or when you're multiplying, it's different. So since I'm subtracting here, when I split it up, they get the same denominator. You can always check your work by looking backwards. If I subtracted these together, would I get the original again? Yes, so we did it right. What does 1 over sine equal? Cosecant. What's sine over sine equal? 1. So we get cosecant minus 1. Was that our goal? Yep. So these are equal.